Welcome, everyone. I'm Michael Littlecrow. So I'll be your instructor for this course. And this is MAT210, brief calculus. Is that correct? I'm in the right place? Okay, we're all in the right place, hopefully. I taught this last spring, and I teach it fairly regularly. It's one of my favorite classes to teach because I've been teaching for 24 years. But before that, for about 13 years, I was in financial planning, business, insurance, all this kind of stuff. So this I like teaching business students. So this approach we'll take to learning about brief calculus will be how it applies to hopefully the field you're in. And occasionally, how many of you are business majors of some sort of business? Okay, that's usual. But occasionally we get a biology major, something who's taking this because they don't have to take the other calculus. So do we have any non-business majors? Okay, good. What are you? What's that? Music. All right, very good. So we'll try to make the content as applicable to everyone as possible. If I'm a little disoriented, I've been in Bangkok, Thailand for the last 3 months. I just got back Sunday night, so I'm still kind of on my jet lag and adjusting. I wasn't sure if I've been up since 4 this morning because I couldn't get adjusted. So then I thought I'd either get here real early or I'd be late, and I was almost late. So anyway, I'm here. Hopefully you've had a good summer as well. Uh, it was a working summer for me, but also a good time to be with family and move forward. So let's see. What I'm going to start you off with is a little story. First of all, we'll see how all my technology works, but I do record each lecture. So the screen gets captured, and hopefully that's what this little Bluetooth thing is it's supposed to capture the sound. Occasionally the first day things don't work out and I get them fixed later, but we'll see. I'll show you in Canvas. I've got all the recordings from spring as well. So if you're in the habit, you want to kind of look ahead, you'll be able to watch the video from the lecture from spring before class or after class. And then what I'll do is each day we have our class or lecture, I will process this video and get it posted probably by the evening, maybe early morning next time. So you'll be able to, it does a couple things. If you miss class, you're able to see what went on in the class that we were in. If I make some special announcement, you get that. If you were in class, you also get to watch it again because sometimes, I don't know, I'm dyslexic, so my learning style is kind of all over the place, and sometimes my teaching style is too. Sometimes I go in circles. But what I found is it's really hard for me to take notes and learn something at the same time. I either have to focus on the learning or I have to focus on taking notes, but I have a hard time doing them both at the same time. So that's why I kind of do this. It'll allow you to have the resources you need that fit your learning style. So and again, sometimes it was starting to make sense, but you lost me or I lost you somewhere along the line. You go back to the video and maybe that picks things back up. So that's why I put that there. A little bit of motivation for this course is a little story I have for you when I was in financial planning. It was in Corvallis, Oregon. Anyone from Oregon? No Oregonians? Wow. Okay, a lonely place here. I spent 40 years in Oregon. I've been here for 20, but I still consider Oregon kind of one of my homes anyway. So I worked for a man named Mike Gray, and he was a financial planner. He had a lot of clients. I worked on the inside, so I did all the proposals and ran the numbers and that kind of stuff. He had a agent in his office who didn't know how to use a calculator, so I would charge him $100 to do his math for him. So it was kind of good. So learning math gives you that ability that if you got someone who's not so good, you do that. But that's not really what the story is. The story is one of our clients ran a Emerald Forest Products, which was a sawmill, sort of. In Oregon, they have a lot of those things down in Eugene. But what he did is they made plywood, and so they didn't have all the other stuff for cutting it up. What he would do is he'd buy the veneer, which is the pieces, and then they would glue them together and make plywood of various thicknesses and such. What he found a way to do, and this relates directly to the calculus I'm going to be teaching you, is he could watch the market and he could predict whether the price of veneer was going to go up or whether it was going to go down. And he just got real good. He would watch the market. And what he was doing was he was doing a calculus calculation. You know, he had never taken calculus. He didn't have a bachelor's degree. He had a high school diploma, but he had been in the business and he could see the rates of change. That's what this course is about, rates of change. So it's not about necessarily where we are, although that's good to know. It's about where we're going with our business. Again, are things going up? Or are they coming down? He could spot those things just intuitively. And so he would either buy the veneer, but not make plywood with it, because he would say, okay, I know the price is going to go up, so I'm going to hold it and I'm just going to sell the veneer back to somebody else and make a profit that way. Or he knew it was, he got very good at watching that stuff. And so he went from a company that was worth maybe about $1 million, which is pretty good, to, and again, this is Eugene, Oregon. This is back, so date myself a bit, this is back in the 1980s, early 90s, maybe, that time period. And he took that company and it was worth $10 million in a short period of time, simply because what he did. He had some children he wanted to turn the business over to, but he could never teach what he was doing. He just sort of intuitively knew. But what he was doing is he's using the tools of calculus that we're going to use to kind of calculate rates of change and know whether the price is going to go up or down, whether to turn it into plywood and make a profit that way, whether to keep it as veneer and then resell it to some other fool down the road who was going to pay more than he bought it for. And he just got real good at that. In fact, when he'd go on vacation, he had a condo down in Hawaii. Hopefully it didn't get burned in the fire, but he would go down and he would get up early morning, 4 or 5 in the morning, watch the markets, do all his work and be done by 8 in the morning, have the full day to be on vacation too, and make money in the booth. So what we'll do in this class is try to tie things like that in for your particular field. So we talked about business majors, and a lot of you raised your hands. How many are into finance? Finance majors, that's usually a fairly large, okay. How about, let's see, what's another field? Business management, administration and management, supply chain. Oh, there's usually more of you in there. What else are y'all? General business, not quite decided yet? Good, okay. Well, we'll see. But we'll look at some applications. And again, what we're trying to get you to see is what we're going to do is what we call the derivative in calculus is the rate of change of things. So it's where we're going, not where we're necessarily at. Although we try to figure out where we're at and then whether we're going to go up or down. Okay. Any questions before we get into sort of the overview, the technical side of the course? Y'all, looks like we got about everybody. I think they capped this class, I think, at 100. We have 115 seats in here. I signed a few overrides, but as typically happens is one person adds, somebody drops. So I think we're still right at about 100. So we do have a few extra seats in here, which is good. I also teach a section of this course on Mondays and Wednesdays. You'll see that I'm using one Canvas course for both of them. So you'll be also able to see what they're doing, their schedule. And I have no problems as long as we have seats, because the Monday, Wednesday class, they're in a room that has a fire law capacity of 89, and there's 89 registered students. What typically happens after the first week, though, is maybe 10 students don't show up every day. So usually there'll be a seat, and I have no problem if we don't want to violate any fire codes either. But if you need to come to that one, it's Mondays and Wednesdays at 3:00. And again, you can look in Canvas to see where that's at, and we can make that happen. Okay, let's make this a little bit bigger. So we'll go over, so here's our syllabus, and you see we got our Tuesday, Thursday class, which is you all, and then we got a Monday, Wednesday class, and we'll be pretty much right on track. Of course, they'll be taking the tests on Mondays. We'll take them on Tuesdays, but this is a coordinated course. I did not write this syllabus. I did change a few things because I thought it was a little draconian, I guess, a little hard that I would say, but I did check everything. So if you find a place that's kind of harsh and kind of, that probably was something I didn't write. I try to put kindness into everything I do. So we'll go over this, but this is a coordinated course. I'm handed the online homework portion, and I'm told I cannot change those. I can't add a problem or take a problem away. It's okay. That's fine. I'm handed the exams. I do not write them. I just give them and grade them. And, but what I can do is hopefully motivate you to learn the content and do well and provide the resources so that you can do as well as you want to do. I, I was up until spring, I graduated. Actually, I'm still sort of a student. I'm still taking a few graduate classes in American Indian Studies because that's an interest of mine. Did finish my doctorate in the spring. It wasn't in math. I'm a educator, so it was a educational leadership and innovation, and I passed all of that, so that was good. But I understand what it's like to be a student, and I believe you'll learn best when you're having fun. So we try to make this as enjoyable as possible. You'll also learn the most when you get some say in how you're going to learn it, when you're going to do it, and those kind of things. So I will work with you flexibly as much as possible. We have this semester to get everything done. You'll find it's best if you can keep on track with the assignments as far as the timing and stuff. But if life happens, as it always does, we can make adjustments. Okay. So I look at our schedule that we're going to take a look at as a strong suggestion that if you can keep up with that, it'll make your life smoother and it'll be great. But if you can't, it's not that it's a failure or anything. We'll work with you and we'll try to get you back up to speed and going on things. Okay. So we got this information. One of the things you will need for this course is the WebAssign. And what I've done is I put I'm using the same WebAssign for both classes. So we'll have almost 200 people in that course. We'll see how that all works, but it makes my administrative part smoother so I can focus on the learning part with you. I guess that's what I was going to say. I guess the dyslexia catches up with me. Is I'm an educator, not a mathematician. I'm a math educator. I tried to be a mathematician. I've studied actuarial science, but that wasn't my calling. So I focus on the learning part. So you could click on this link right here. It'll take you to the place you need to be, and it'll actually put the code in, and it'll say, this is Little Crow's class. You register for it. It costs $100, I think it is. And I think you get like the first 2 weeks free. So if you don't have the money right now, you can at least register and get started in it. And I think that's how it works. You could also go to the webassign.net and actually type in the code, whichever works best for you. But we do need to get that. That's where the homework is done. So today we will take a look at the first section that we're going to look at. It's not too heavy duty. There's 9 homework problems. If you can get those done over the weekend, we'll be ready to go next week. You'll see the Monday class is going to do 2 sections on Monday because they kind of start like half a week behind us. And then they are going to have a little bit more trouble because it's only Monday, Wednesday. There's several Monday holidays, so they're going to lose several Mondays. So their schedule's a little tighter, which means we have a little bit more leeway in this class, in this section. Okay, so any questions about the textbook or the requirements? Just that WebAssign, do that. There has an ebook involved in it. We don't really use it too much. I got some of my presentations and PowerPoints come from the textbook, but the problems that you'll work will be there. Okay. Let's see. These are the learning outcomes. I don't pay a lot of attention, but we will do all of these things, whatever they are. But for me, again, it's easier to do them and then say they're done. And then when I come back, I'll say, oh yeah, we did all that. But if I look at the beginning, I don't even know what all those sections are, but they're descriptions of what we'll be doing. So here's the textbook is embedded in the WebAssign. So if you get that, you're fine. You do need a graphing calculator because some of the things we're going to do in solving problems, it's just going to be much nicer, easier to do with a graphing tool. In fact, there'll be some things that are almost impossible to do without it. And that's what happens in mathematics. There's a whole field of mathematics called numerical analysis that has all these techniques that basically the calculator has taken over and does for us. So borrow one, get one. On Monday, I'll show you there's something called NumWorks, and you can go to I think it's numworks.com. You can download a free, it's sort of like a calculator app onto a phone, a tablet, onto your computer. But the thing this is the only one I've seen that does it. You can also order a handheld version of it for $99. So you could test it out first, and it's a little bit more user-friendly than the TI-84 calculator, which I got that as well, and we'll use that in case you've got one of those. But the num works, if you don't have a calculator, that's kind of what I would suggest doing. And again, I'll put that out in an announcement with some links and stuff if you're interested in that. And again, you can download it, put it on a phone or tablet, use it, make sure it's working. The only thing is when we come to test, as you're going to see, you can't use a cell phone in the test, but you could order the $99 handheld version and you'll already know how to use it. It's exactly the same. It's very intuitive. But we need some sort of graphing calculator. Let's see. We've got listing of dates here of when we're going to have exams. There's another document where I have a calendar laid out of when we're going to cover each thing for each class. So there's a Tuesday, Thursday calendar. There's a Monday, Wednesday calendar, and you can compare those two. But these are the dates you definitely want to have somewhere. The Tuesday, Thursday class, Tuesday, September 19th, October 24th, November 14th. And then the final exam will be, is what do they call it? A common final exam. So we all meet Thursday night, both sections, all sections. We'll figure all that out when we get there, but have those times reserved. So just know that in December 7th, you need to be here through that time. Don't try to get I got a good airfare that I can get out December 6th. You've got to be here December 7th to take the exam. Okay. And then basically our homework's 10%, our quizzes 15%, exams are 50%, and then the final exams 25%. So it's kind of math department policy for about 75% to be exams. Yes. Yes. You get, there's some place in here that talks about it, but you get 5 attempts on each homework problem. So you can submit it, see if you got it right. Now there's some that are multiple choice, and depending upon the multiple choice, so like if there's only 2 choices, you get 1 attempt, because if you got 2 attempts, you'll get it right the second. If you got it wrong the first time, it's a true false type thing. So there are a few ones in there that are that way. What I do is there's also a few questions where you can put it in correctly or something that is a correct form, but it's looking for something else. So I typically will round up. So as long as you're getting about 90% on your homework, I'll make sure it's 100%. Okay. Actually, it'll be 105. So if you get your homework done 24 hours before the due date, and I give pretty generous due dates, the system will give you an extra 5% on whatever you did before that. Okay. So kind of encouragement to try to stay a little bit ahead rather than getting behind. I liken that to surfing. Again, I did some body surfing, but not any serious surfing, but they allow us up to 1% of the total grade. And we'll find a creative way to do that. I haven't got anything right now, but who doesn't like extra credit, right? So we'll come up with something. And it'll be something that helps you with your learning and maybe a project and those kind of things. Okay. So I don't do pop quizzes type things. And sometimes what I envision doing with the quizzes is using them as sort of a review when we get to the review for the test, to have some things basically, and you'll be able to earn that just by doing. It's not going to be there's something called formative learning where it's okay to make mistakes, but you've got to engage. So as long as you're working at it, engaging and completing it, you'll get all the quiz points too. It's not the exams. That'll be the 75% where it is graded. Okay. So you need correct answers and those kind of things, but the other 25% effort and engagement. Okay. And then the 1% extra credit will be, do something. Any other questions? Yes. It's just for the homework. So the homework portion, and what I can do is I may move some of the quiz over to the homework, because I think that's where I usually more focus. So probably make the homework about 15% and the quiz is 10%, something like that. We can do that. But so then that 5% helps out a little bit more, because it's 5% of the grade. So it's actually, since it's 10% right now, it's only 0.5%. But if I make it 15%, then it's 0.75%. So a little bit more. Good for pointing that out. And then there's the grading structure. And again, that's set by the department. Let's see. This is more links to get into WebAssign. Short quizzes will be given frequently. Not really. We'll just kind of keep moving. The homework will pretty much do it if you keep on track with that. And then as we get closer to the exams, we'll have some other learning activities And see that we go till, see, we start at 7:30, we go till, thank you. So keep me on track, and we'll today try to probably sign off by 8:30. So we have 15 minutes for anyone who has questions and such. So we'll address that. My next class is at 9 o'clock downstairs somewhere, so I don't have too far to go, and we'll make it all work. Okay. This is, I don't know. It makes syllabus is like such a legal document. There's all this stuff that, read it if you like it, kind of from the handbook, or, you know, these are my 2 rules. I only have 2 rules in my whole class, and it's all based on 1 rule. So there's, maybe it's 3 rules. I don't know. The 1 rule is that you have to accept that, we have material things that we have around us, but do we really own them? I don't think so. I mean, we have possession of, we use them. This is my computer, but hey, somebody could take it from me. It's now no longer my computer. So, but what we do own, the thing we do own, is our actions. Okay, we have multiple actions. Our thoughts are like our actions, because usually when we think of something, we'll follow it up with an action. So, if we accept that we're the owner of our actions, we did it. Sometimes we did something unintentionally, but if we did it, right? So we're the owners of our actions. Then that what goes with that, there's only really 2 types of actions that we do: skillful actions and unskillful actions. Can someone help me out? What would be the difference between a skillful action and an unskillful action?
Well, like you were saying, between materialistic and enjoying and just material.
Okay, so that idea that skillful is going to get you to where you want to go. Unskillful kind of hinders you from being where you want to be. And sometimes the same action could be skillful for one of us, but unskillful for another one of us. Listening to music while you study. For some of you, that's a skillful use of your study skills. For others of us, I get into the music and I stop studying. So it's not very helpful for me. But I've worked with students where, they had an accommodation where they're supposed to be in a quiet room during testing, and they weren't doing very well. So she says, well, can I make it up? This was at a community college I was at. So I said, yeah, but you're going to have to do it in class, because I still have to proctor it, and we've got things going on, and it's going to be a little noisy. What she did is she did wonderful on the class, on the test when it was noisy. And she says, I could think so clearly because I had this background. She goes, when I'm in a quiet room, it's too quiet. So for her, we did this. We switched her accommodation. We want to be in a noisy room, but was much better for her. That was more skillful than what people were saying. You need to be less distractions and stuff. The more distractions there were, the more she was able to focus. Okay, so that's a skillful thing. The other part of skillful and unskillful is there's sort of this overriding rule or concept. Anything that hurts another or ourselves is by definition unskillful, right? If we're causing harm, that's an unskillful action, whether to ourselves or to others. So those are my rules. Try to be as skillful as you can be. When you find yourself being unskillful, try to get away from that and work towards being more skillful. It's not about sin and doing good it's just about getting to where we want to be. Okay. So I could take a syllabus and say, I don't need all these rules. I just need 2. Try to be as skillful as you can, because that's what you want anyway, right? You want to get to where you want to go. Okay. That's it for that. So then let's see what else I have. I've got anticipated schedule Tuesday, Thursday. So I'll click on that, and you'll see it's a PDF file, and we've got a course calendar here with the exam dates and everything. You can print that out if you want, or whatever works, but embed those. What I'd like you to do is, as far as the due dates and the homework, I tried to move them out further. But if you can stick sort of with this, you'll always be on track with the due dates. In fact, you'll actually be a little bit ahead. And again, I can always move those due dates either individually or as a group if we decide we need to. I have no problems with that. But it's like, by the time we get to the first exam, we have to have gone through all the stuff that's going to be on that first exam and had time to review it. So that's all there. I've got it laid out in Tuesday, Thursday format. We have one holiday, the Thanksgiving, but other than that, all the other holidays this semester are either on Mondays or Fridays. So we only get one. So that's the layout of the course. And then I've got basically a screenshot of just the part of the calendar that will get you to exam one. So that's what I'm going to do. And I think I've got everything else, nothing else showing except what's going to get us to exam one. And because it just kind of no distractors. So we've got this module here, take us to exam one. We'll take a look at each of these sections. And so if you go into the module, what you'll see is there is a pre-recorded lecture here. I think this one was I couldn't find the one from last semester. This one was, I believe, for when maybe it was. No, I think this was from the fall 2020, the first full semester after the COVID lockdown when we were all virtual. So I had to make them for those. So if you go there, I've got them all stored in a playlist on my YouTube channel. So if you want to just go to the YouTube channel and take it there, you can browse through those MAT210 videos. And you'll see as we get close to the exams, I will work through the practice exams and give examples and all those kind of things. So all those will be there. The other thing I will do is once I post this recording, which hopefully it's working out, this thing keeps buzzing in my ear that it's connecting and unconnecting. So I don't know how the sound's going to be, but I'll post this video and that'll be here. Each one of the modules will have a link to a slide deck, which are basically the notes and what I'll use for the lecture. Let's see. But before I do that, let's see. I need to let's turn this on. Okay. So we'll just kind of slide into this first section, 10.1. It'll be, I think, 9 homework questions that are involved in this, and probably be done with our first lecture in 15 or 20 minutes. Okay. So the first concept is what we refer to as limits in calculus. And what's a limit? We'll go through it, but in this section, we're going to look at it numerically and graphically. So this is where we'll need a graphing calculator to do some things. But basically, the concept of a limit is this idea in calculus that what is happening mathematically to a function as we get close to an input value. So if we're thinking of a graph of x and y, as we get close to an x value, what is happening to the y value of that function? Okay. We're going to see in algebra, we just say, well, that's the value. We go to the graph, we look it up. This x has that y value. And sometimes that's what a limit is. But the limit is also going to help us when we go to an x value and there is actually no y value. There's sort of like a hole in the graph or something. That's what we're going to use limits. That's when we have to have limits. But we're also going to just take a look at it on a general function where, you go to that x, you go look at the y, that's its limit because the value's there. Okay, so we're going to start with that and then move forward. So here's the basic idea. We're going to evaluate them both numerically. When I say numerically, we're going to plug it into a graphing calculator. We'll look at the table of values. These are the x values. These are the y values. So we look as we get closer to, say, an x value of 3. So we go to 2.9, 2.99, 2.9999. What is happening to that y value? That's what we're going to do. Okay, so that's numerically. Graphically, we'll take that same function and we'll graph it and we'll look visually what's happening as I get close to 3, what's happening. So we'll do both of those two things in here. We're going to look at the x input value, which is the x. That's referred to as the domain. All the x's are the domain. And then the limit itself is defined as the value of the limit is the y value that we're getting close to, or the range, the range of the function. So what we're doing is we're trying to get as close to the x value that's given. So they say when x equals 3, what is the limit? So as we get as close to 3 as we can, what's happening to the y? The concept of limit is we have to be able if 3 has 2 sides to it, it has a left side and has a right side. And we're going to see that the limit will exist if both coming from both directions, we end up at the same place. If coming from the left and the right, we end up at different places, then we say, oh, that's not a limit. That's, is a jump. So we'll look at a few of those examples. But it's sort of, we're trying to kind of build an intuitive feel for what a limit is. Recognizing that it's kind of a very technical mathematical tool that's used. What we're going to use it for is, well, we'll get to that in the next section. So this is kind of what we're going to do. So here's the idea is this is the way we write the notation. Limit, LIM, is the mathematical word we use for limit. Let's see. So this is telling us we have a limit. Right here, it's telling us what the input value is getting close to. So we're going to 3, like I was saying. And then over here is the function value, or the function, right? So one way we could do is we could just say, in an algebra, this is what we do, right? We'd say 2 plus 3 equals 5. And that's the answer. That I put 3 as an input, I get an output of 5. We're going to see in this case that also works when we think of limits. But what we also want to be able to do is we want to be able to do this numerically. And so this is a little bit of overkill, but I just want to, let me see if I can pull up my NumWorks calculator. So I got it right here. I downloaded it. And so there it is. So I'm going to put that into my graphing calculator. Go over to graphing. So this is the one I was talking to you that you can download for free. Use it. And then if you really like it, you can order it for $99 and they'll send you a physical version of it. So I'm going to graph, and our function was, let's go with OK. I'll leave it empty. Let's see. Is going to be x plus 2, right? Or it was 2 plus x. I guess let's 2 plus x. Same thing, but let's go ahead and just kind of do it that way. And then what I'm going to do is I'm going to go up and I'm going to go to the table. And what we want to see, there it is, when x is 3, y is 5. So we might think, but again, what we're running to do with limit is not see what exactly it is at 3, but what it is as we get closer to 3. So I can go in here. I'm going to change this to 2.9. And we see that that's 4.9. Now, well, let's go to 2.99. That's even closer to 3, right? Oh, 4.99. And I do see that this is the concept of limit. As I get as close as I want to 3, my output values is getting closer and closer to 5. So that's the concept of limit. In a homework problem, we just say the limit's 5, and we got it just by plugging it in. Okay, so that works too. We're going to look at mathematically, they even have a rule that says, hey, you can do that for most of the cases. But we're also going to look that this is a way of examining something that might not have a value at 3. It might be like a hole in the graph, but we're looking as we get close, what is it going to be? And as long as the limit exists, then we can pretend that there's something there. So it's kind of a nice tool to have. But is that kind of clear? And I guess, to be accurate, what I should do is come from the other side, is I should be, as I go away from 3, so this would be 3.001, right? That's pretty close to 5. So from both the left and the right side of 3, I'm pretty close to 5 either way. One side I'm a little bit above 5, the other side I'm a little bit below 5, but as I get closer to 3, I'm going to be at 5. That's the concept of limit. That's what it is. Let's see. Let's keep these. Any questions so far? Now let's take a look at this one. Got a limit. X is going to 2. We could plug in 2 up here. 2 to the 3rd power. 2 times 2 times 2 is 8. 8 minus 8 is 0. So we got a 0 in the numerator. What happens in the denominator? 2 minus 2, 0. We get this beautiful answer of 0 divided by 0, which is what? It's indeterminate. We can't say it's 0 because you're dividing by 0. So one thing was to say it is 0, but the other thing is 0 divided by 0. You've got the same on the top and the bottom. That should be 1. So it should be either 0 or 1. The thing is if you choose one or the other, the rest of the universe blows up. We don't want that to happen. So mathematicians, being the courageous people we are, we just say we won't deal with that. So we call that the indeterminate form, and we really don't know. What we're going to see in this case is when we do it numerically, what's happening when we get to 2 is that's where there's actually this hole. Everything else works except for 2. 2 gives us this hole that nobody has the courage to say whether it's 0, whether it's 1, or whether it's infinity or whatever, because you choose one or the other and the rest of the universe doesn't exist or something. No, it's one of those mathematical things. So again, what we'll do is we'll come to our calculator, and yeah, we're right on track. Once we do this one, we're in good shape. Let's go, see, go to expressions, and I'll change this one here to, what was it, x to the third minus 8 divided by, was it, x minus 2. And again, we're going to look at the table, see what that gives us. It gives us these. But again, we're interested what happens when x equals 2, so I'll just put that there. And you see at x equals 2, our calculator's smart enough to know that that's undefined. It's not going to touch it either. It's not going to say it's 0. It's not going to say it's 1. It's not going to say it's infinity. It's just, I don't know. So all we can do is use this tool, sneak up to 2 on both sides. So let's come, instead of 2.9, let's look at 1.9. And then let's look at 1.99. Again, we're getting closer and closer to 2 from this side. And what does it look like we're getting close to? Oh, is it too small? I have to take my glasses off I'm nearsighted, which means I can see fine if I'm near, but I can't see far. Actually, see if I go like, there we go. 11.94. What does it look like it's getting close to? 12. And let's go to 1 point. And we're pretty close to 12. Okay, so that we could say that. And we could also, again, looking numerically, we want to be just a little bit bigger than 2. So we'll go to 2.000001. So we're not at 2, but we're very, very close. And it says it's 12. In fact, it gets so close, right? But we know when we just put in 2, we get an undefined. So this is where we need a limit. But if we looked at the graph, both the left and right side are going close to 12. There's actually a hole there when x is 2. So it's not really a point. But now we can pretend that it's 12, and we can do the math. And because we live in the real world, right? Our businesses, we can operate and we say, okay, I'm at 12, and now I'm going to do the math from there. So that's what the limit allows us to do. Sometimes we have to do a little bit, play this game with it because, again, it's undefined. But you'll see it in a lot of the homework problems. All you really have to do is plug in the x value, and you're able to get a y value. And that's fine. That's all you have to put in. Okay. So we're good on time. So let's look at take a graphical look at this. So now we've got this function that's a graph that it's not we don't have any place to put it, but we're saying as x gets to 6, which is right here. So what we're doing is we're coming from this direction and this direction, and we want to know the output value. So we're down here on the graph. As the x value gets close to 6, the y value looks like it's going to get close to, what is that? -4. Thank you. And if we come the other direction, again, the y value is going to the same place. And this is a continuous function. It actually does exist there. So if we had this graph, we could just say the limit is equal to -4. Okay, but we're using this concept of limit. So it's sort of like what we did in algebra. Just look at the graph, look it up. But it's also going to apply when there's actually not a point there. How about this one? As x gets to 2. So again, here's the x2. So we're coming from the left and the right. And so we follow the graph this way and this way. And it looks like from both sides, they're both going to the same place, which is -2. So we could say that this limit is equal to -2, just like that. And again, there's a lot of theories behind this. And if you read a math book about it, it'll probably confuse you more than anything, but that's all that's really going on. Sometimes that's what the thing with math is math is so much about getting a very concise definition of what they mean they're talking about is they confuse the heck out of all of us, right? I've tried to teach myself just by reading a book, and a lot of times I just confuse myself. I go talk to my professors when because I was a math major. Then they would explain it something like this and say, okay, that's all. Forget about the 3-page explanation. It's just this. Okay, now here we go. What do you think about this one? Kind of similar, but what's happening? So again, we're going to x equals 2. Here's the idea of limit. But in this case, if we come from the left side, where do we end up? -2. If we come from the right side, where do we end up? Are those the same number? No, very different. So we would say that these limits don't exist. Now, we're not going to get into the technicality of this in this class, but there are actually two types of limits. There's one as x going to 2. They would have the negative here. That means that coming from the left, that limit does exist, and that would be -2. So I'll just so the limit coming from the left would be -2, and the limit as x goes to 2, and they use the plus coming from the positive direction, that also exists. It would be 0, but since they don't match, they're not the same, the left and right, we just say that the limit itself does not exist. So up here we say that's a D, does not exist, D and E, something like that. And they'll in the homework, they might want you to say undefined. They'll tell you what that answer is. If it doesn't exist, put this in there. Some systems just use D and E does not exist. That limit doesn't exist. Again, the left limit exists, the right limit exists, but since they're not the same, the whole thing doesn't exist. Does that seem pretty clear? Okay, good. And this is, again, where I tell you in math, they're going to talk about a closed form. What all a closed form is most of the stuff we're dealing with is closed form. So you could kind of read through this later if you want, but I'll give you examples of what closed form means. It's any kind of it's most types of functions we're going to deal with that are a combination of different things, right? But you can write basically a single formula, a single expression, and that's what's called closed form. Something that's not closed form is down here is a piecewise function, where you need like 3 different pieces. And what typically happens there is each piece may not line up with each other, right? That's where we get those jumps. One piece might end here, the other piece starts up here. We got this whole sort of jump in between. But if it's in closed form, the mathematics behind everything we're doing is we're going to see that they're pretty much continuous, and we can just plug the value in. We can do the algebra. Algebra will get us where we want. It's when we start dealing with the piecewise functions that at those boundary places, we need to apply this concept of limit to see if things are going to happen right. Okay, so that's all it says is if we've got a closed form, we can just plug the value in just like we were doing in that first example. Plug in 3, we got 5. That's the limit. That's all we have to do. We could do that for any closed form function. Problems is where we get like division by 0, like that x minus 2 in the bottom. Then we need to use limits. That's it. So we'll end with this. My last example, taken right from the homework, actually, similar to the homework at least. X going to 1. Is this a closed form function? Yes, because it's a single expression. What can we do with that x equals 1? Do we have to put in our calculator and go 0.09, 0.999? No, we can just plug it in and sort of do this algebraically. So we get 1 raised to the 3rd power minus 8 over 1 minus 2. 1 cubed is still 1. 1 minus 8 is -7. 1 minus 2 is -1. And -7 over -1 is +7. And if you plug this into your calculator, which you might still have it in there, you can see when you plug in 1, you get 7. So we could have, so we've still got this. Let's see, where are we? Let me just plug in 1 here. And we got 7, because that's the same thing. So that's the limit. That's a limit thing. So a lot of times in limits, it's just what we've been doing in algebra. But what it's going to do is it's setting us up for our next section, which actually we don't go to 10.2, we go to 10.3. And we're going to look at limits at infinity. And what we're going to do is business-wise, what that means, I don't think I completely agree with this, but they use infinity to represent an unknown time. So you're running your business and you just know in sometime in the future something's going to happen, but you don't know when. They call that infinity. So we use infinity to analyze that and say that we don't, if it's an unknown time, let's use infinity and let's see what happens. And that's where we're going to see we bring in limits. That's what we'll do next week. So what you should be doing, almost there. Oh yeah, we go till 8:45. I was shooting for 8:30. I might even get done earlier than that. But let me just show you WebWorks real quick. WebWorks, right? WebAssign. WebWorks is what they use for the engineering calculus. And I've taught that one too, but I like this one better. This is more conceptual. Let's see if I put that. I have to remember all these logins. I think that's it. So when you do register, if you've already registered, you might have seen some of this. It might look a little different from your perspective. We want to go into 10.1 homework. So I can go and view the homework assignments. So you see there's 9 questions. And I just want to kind of highlight, this first one, estimate the limit numerically. So again, you could put that in a graphing calculator and plug in numbers that are getting closer and closer to 0. But because this is also closed form, if we plug in 0 for X, we will also get that same answer, right? So you see, this is sort of what we just did. Here's another one. You're going to plug in 11. And again, it's closed form. So we could just plug it in for X and get it. But I encourage you also to kind of play with it a little bit, look at, put it in your graphing calculator, look at the table of values and kind of figure out how to get closer and closer to 11. So that would be 10.9, 10.99, and see how it works. Play with it a couple times and then, you want to get it done. So move forward. So a lot of these are just, just plug in the values and you're going to get it and it's all going to be fine. Let's see. These ones, similar type thing. Here's a graph. And again, so looking at the graph, they'd use D and E if it doesn't exist. As X gets towards 0 here from the left, the right, it's going towards 10. Again, you might get something a little different, but anyway, pretty much what we tried out. They have revised this class considerably from what it was about 2 years ago. There used to be a lot of need for algebraic factoring. They went through because the business school said, we want to see greater success and we want you to teach what we need. And we don't need factoring in the business school. We need them to understand the concepts. So you're not going to need to do much factoring in this class. And that's this first 2 ones. That was the hardest part of it, is they had a lot of types of problems where you had to do some algebraic factoring and all this manipulation. We're getting you to something where you're going to focus more on the concepts. Okay. So again, go through there, do those. You get multiple attempts, up to 5. If you're not getting it right after 2 or 3 tries, maybe send me an email, and because maybe you're either putting it in wrong or sometimes there's a way they want things in, but anyway, we'll work on it. But try not to use all of them and then come to me and say, I used up all my attempts and I wasn't getting it right. After the second or third time it was marked wrong, let's talk and let's get some understanding what's going on, and then we'll do that. And so I got it so that the due dates are always like a Tuesday evening afterwards. So we'll cover it. You'll have at least a full week to work on it. And there's always at least 1 or 2 class meetings in between where we can ask some questions and make things. But you can also send it through email. And a lot of times I can answer questions. You take a screenshot and show me what you're doing. I can respond back to you. And a lot of times it's a little simple thing. And I only know these because somebody else told me about it. And, so there's all these technical things. Any questions? Nobody left during the lecture, so that's a good sign. And especially if I don't like seeing people leaving in anger, so that's good. So hopefully you're looking forward to a great semester. I am. getting through this successfully and moving forward in your career and being that person who goes from $1 million of value to $10 million on your business value, or 100 million, whatever it is that you want to do that will make it happen. Thanks.
Thank you.